Okay, Kiana, so you sent me 4 pages of your lab. In the first page, we talked about number 1 and number 2, and then number 3 is worked like one of the problems that he has in your notes and that we worked a bunch of times. So on this next page, I read what the experiment's supposed to be doing. And then on the, let's see, I don't know how well you can see that. But on the velocity table 1, it looks like you're doing everything correctly. And on table 1, for the distance, I think that it's going to be the 10 centimeters that is the sail distance. That's what I think. And so you figured out the acceleration measured using this formula, and so that's good. And it looks like you did a good job. And then acceleration predicted using this formula, and so that looks like you did a good job. And the percent difference is 0 based on your results. So then for velocity table 2, for the next page, do velocity table 2 the same as you did for number 1. And then for table 2, do it the same as you did for table 1, except it doesn't have an acceleration predicted column, and I think you should have one of those there because number 6 asks you to determine the percent error. And the percent error is going to be the acceleration. You're going to get an average of the acceleration measured and an average of the acceleration predicted. And then you're going to plug it into this equation to get percent error. And then as for the 3 questions here, for possible errors, I'm thinking that the pulley has friction and we pretended it was frictionless. Maybe as humans you guys didn't measure things correctly, and maybe the equipment wasn't accurate. For what would be the best way to change acceleration, that would be to change the mass, because acceleration is force over mass, and it says if you keep the force the same, what can you do? Well, there's only one thing left to change, the mass. Now it says, let's say while performing a run, the hanging mass reached the floor. What would be the acceleration of the glider after the hanging mass reaches the floor? For this one, I'm not really sure, because part of this kind of problem is that this is hanging, and so its weight is the tension that is the force that pulls it this way. So if it's sitting on the floor, its weight's being canceled out by the normal force of the floor pushing up on it. So I'm thinking that there's no tension in the string, and so the force would be 0, so the acceleration would be 0, but I don't know for sure. Okay, and then the last thing you have to do is you have to do a graph. And so from looking at your table 2, I saw that your smallest force was about 15,000 and your largest was about 45,000. So for your x-axis, it's going to be force, because that's what they told you to do. And so I kind of just divvied it up into 15,000, 20,000, 25, 30, 35, 40, 45. And you should probably extend this and go up to 50. Now, once you do to table 2 what you did to table 1, you'll have 4 different measured accelerations. And so you'll look at the smallest number and the biggest number, and you'll spread it out along here. And then, so the first force was like 15,000-ish. And so you'll mark a dot somewhere along here based on what the accelerated measure was. And then you'll do the same thing for the one that was 25,000-ish. And you'll do the same for the other 2. And then he'll probably want you to connect the dots. Okay, good luck.